Provisional Patent Disclosure and White Paper Preprint Series 2. Autonomous Deep Bore Electromagnetic Tunnel Machine and Integrated Intercontinental High-Speed Transit System. Inverted Traveling Wave Electromagnetic Propulsion, Promethium Plasma Rock Fragmentation in situ Bore Wall Dielectric Substrate Synthesis, QLAG Coupled Autonomous Navigation Schumann Resonance Phase Balanced Seismic Management. Notice of Intellectual Property Rights. The concepts, systems, and methods described in this document are the original invention of Chris D. Seeley. This disclosure is filed as Series 2 of a family of related inventions to establish a priority date and provide constructive notice of inventorship. Unauthorized use, reproduction, or commercialization of the described technology without the express written consent of the inventor is prohibited. Abstract. This disclosure describes an autonomous deep-bore electromagnetic tunnel machine and integrated intercontinental high-speed transit system, a unified invention comprising an inverted traveling wave electromagnetic propulsion system in which the progressively constructed bore wall serves as the external stator and the drill train assembly serves as the magnetically coupled secondary. Propelling the machine forward without mechanical thrust bearings or external hydraulic rams. A Promethium plasma rock fragmentation and maser-assisted cutting head capable of continuous full-face boring at depth, an onboard debris processing train that pulverizes, polymerizes, and vulcanizes cut rock material into a magnetically encoded dielectric elastomeric substrate, which is applied in situ as the bore wall lining, serving simultaneously as structural shell, waveguide, electromagnetic stator surface, thermal barrier, and sealed transport tube. A high-speed passenger and freight transit system operating within the completed bore using the same inverted electromagnetic wave drive principle at intercontinental speeds. Navigation and position control via coupling to the Quantum State Global Network Quantum Local Area Grid System, providing GPS-denied autonomous navigation at nanometer accuracy at any depth, and Schumann resonance phase balancing technology integrated into the bore infrastructure to provide passive seismic load management. The combined system enables intercontinental tunneled transit at costs and speeds dramatically superior to any prior Hyperloop rail or pneumatic tube proposal, with a fully sealed, self-cleaning, inert bore environment requiring near-zero maintenance. 1. Field of the invention. The present invention relates to autonomous tunnel boring machines, subsurface transit infrastructure, electromagnetic linear propulsion systems, plasma-assisted rock fragmentation, in situ construction material synthesis, and quantum-coupled inertial navigation. More particularly, the invention describes a complete system in which a self-propelling electromagnetic drill train bores lines, and commissions a high-speed electromagnetic transit tube in a single continuous operation, using the rock material it removes as the primary construction substrate for the bore lining and propulsion surface. 2. Background and prior art. Conventional tunnel boring machines advance through rock and soil using a rotating cutter head pressed against the face by hydraulic thrust rams reacting against segmental concrete rings erected behind the machine. This architecture imposes several fundamental constraints. Thrust force is limited by the compressive strength of the erected lining segments and the reaction frame geometry, practically limiting advance rates in hard rock. Excavated spoil must be conveyed rearward by belt conveyor or slurry circuit, a significant logistical burden accounting for 30 to 40% of operational cost. Lining segments must be manufactured off-site, transported to the tunnel portal, and conveyed to the erection position, creating a supply chain dependency that limits achievable advance rate. Navigation relies on laser theodolite survey chains, which accumulate error over distance and require periodic re-zeroing from surface control points, impractical at intercontinental scales or mantle depth. No existing TBM system recovers excavated material for use as a structural or functional bore lining substrate. Hyperloop and other proposed high-speed tube transit systems rely on externally manufactured tube sections, complex sealing and evacuation systems, and wheeled or magnetically levitated vehicle designs that are mechanically coupled to the tube structure. No prior proposal has described a system in which the tunnel boring process itself creates the tube lining and installs the propulsion infrastructure as a single integrated operation. The Promethium plasma cutting technology and the Quantum State Global Network Quantum Local Area Grid Navigation System are separately patented inventions of Chris D. Seeley, referenced herein to describe their integration into the present system. The Schumann Resonance Phase Management System is similarly a separately developed technology referenced herein for its seismic management role. 3. Summary of the invention. The present invention provides an autonomous deep-bore electromagnetic tunnel machine and integrated intercontinental high-speed transit system comprising the following principal subsystems, each described in detail in Section 5. 1. Inverted electromagnetic wave drive propulsion system, an external traveling wave electromagnetic stator progressively constructed on the bore wall, driving the drill train forward as the magnetically coupled secondary. 2. Promethium plasma, maser cutting head, a full-face rock fragmentation system using directed plasma discharge and maser energy coupling for continuous advance hard rock boring at depth without mechanical cutter wear. 3. Onboard debris processing train, a mobile processing facility that receives fragmented rock, pulverizes it to controlled particle size, blends it with polymer binders and magnetic composite additives, and extrudes the resulting compound as the bore wall lining substrate. 4. In situ bore wall lining and stator surface, the applied substrate simultaneously serves as structural shell. Electromagnetic stator surface with encoded magnetic pole pattern, dielectric waveguide, thermal and pressure barrier, and intertransit tube surface. 5. High-speed transit system, vehicles magnetically coupled to the bore wall stator surface and propelled by the same inverted wave drive principle at intercontinental operating speeds. 6. QSGN/QLAG navigation integration, continuous coupling to the Quantum State Global Network providing nanometer accuracy positioning independent of GPS, surface survey, or line-of-sight reference. 7. Schumann Resonance Phase Management, bore integrated electromagnetic emitters tuned to maintain constructive Schumann resonance phase relationships along the bore axis, providing passive seismic load attenuation. 4. System Architecture Overview. The ADETM IHTS is conceived as a train of modular sections advancing continuously through the Earth. Reading from front to rear, the drill train comprises 5. Detailed description of preferred embodiment. 5. Detailed description of preferred embodiments. 5.1 Inverted electromagnetic wave drive propulsion. The propulsion architecture of the ADETM IHTS is the direct inversion of the Tier 4 cylindrical pipe embodiment described in Seeley UESPP Series 1 and Series 1. The coil array lines the inside of a pipe and the traveling wave field drives material through the bore. In the present invention, the coil array is embedded in the exterior bore wall, and the traveling wave field drives the drill train, as the magnetically coupled secondary, forward through the earth. As each new section of bore wall lining is applied and cured by the lining extrusion module, the embedded coil array in that section is energized by the drive electronics train, extending the active stator surface forward. The wave drive interface ring on the drill train presents the magnetic secondary pattern to the bore wall stator and receives propulsive thrust. This architecture eliminates the need for hydraulic thrust rams, reaction rings, or any mechanical coupling between the drill train and the bore wall. Force scaling at tunnel scale. For a bore diameter of 10 meters, the circumferential stator surface area available for wave drive coupling is approximately 31.4 square meters per meter of bore length. With a working magnetic flux density of 0.5 T and a pole pitch of 150 mm and a drive frequency of 2 to 8 Hz during boring operations, the available propulsive thrust per meter of active stator length is calculated as follows. Thrust approximately equals B squared times coupling efficiency factor approximately equals 99 kilonewtons per square meter at B equals 0.5 T over 31.4 square meters per meter of active stator, and with 10 to 20 meters of active stator length simultaneously engaged. Available thrust ranges from approximately 31 meganewtons to 62 meganewtons, comparable to or exceeding the thrust force of the world's largest conventional TBMs, delivered without any mechanical contact between the drive system and the bore wall. Drive frequency is reduced during boring to match the slow advance rate and increased progressively as the bore is completed for transit operations. 5.2 Promethium plasma and maser cutting head. The cutting head of the ADETM IHTS employs promethium plasma technology in conjunction with directed maser energy coupling to achieve full-face rock fragmentation without mechanical cutter contact. Promethium plasma discharge creates localized superheated plasma channels within the rock face at controlled depths and orientations. The rapid thermal expansion within these channels fragments the rock along natural cleavage planes and induced fracture networks. Maser energy is directed into the rock face simultaneously to preheat and stress the material at depth, reducing the plasma energy required for fragmentation and allowing deeper effective penetration per discharge cycle. The combined effect produces fragmentation of the full face to a controlled particle size distribution optimized for the downstream debris processing train. Advantages over mechanical cutting. Zero mechanical cutter wear, no disc cutters, drag picks, or cutting bits to replace. Effective in any rock hardness, including ultra-hard formations that severely limit conventional TBM advance rates. Fragmentation energy is deposited precisely within the rock mass, minimizing overbreak and preserving bore wall integrity. Particle size distribution of the fragmented material is controllable by adjusting plasma discharge parameters, optimizing feedstock for the debris processing train. No water or compressed air required at the face for dust suppression. Plasma discharge ionizes and captures particulates. Operating depth is limited only by thermal management and power delivery, not by equipment pressure ratings or mechanical wear, enabling true mantle depth boring. 5.3 Onboard debris processing train. Fragmented rock material produced at the cutting face is received by the debris processing train and subjected to the following sequential processing stages. 8. Primary crushing to less than 50 mm particle size using high-frequency vibratory impactors. 9. Secondary milling to less than 500 micrometers controlled particle size distribution in a continuous feed attrition mill. 10. Mineral analysis and sorting. A real-time spectroscopic analyzer classifies the milled material by silicate, carbonate, and oxide fraction. Fractions with high dielectric constant are preferentially routed to the substrate blend. Surplus material is compacted into ballast modules for use as bore-way fill or structural aggregate. 11. Polymer blending. The selected mineral fraction is combined with a thermoplastic elastomer binder and a bonded-in Feb or SMCO magnetic composite additive at controlled loading fraction. Blend ratios are adjusted in real time based on mineral analysis output. 12. Magnetic pole encoding. The blended compound is passed through an encoding die equipped with a precisely pitched permanent magnet array that imprints the required spatial pole pattern at the correct pitch for the bore wall stator function. Prior to extrusion. 13. Thermal cure. The encoded compound is thermally cured in a continuous belt press at 160 to 220 degrees Celsius depending on binder system, producing a dimensionally stable, structurally rated, magnetically encoded elastomeric sheet for application to the bore wall. 5.4 In situ bore wall lining as integrated infrastructure. The cured substrate produced by the debris processing train is applied to the freshly bored wall by the lining extrusion module in a continuous circumferential wrap, maintaining dimensional tolerance of plus or minus 2 mm on bore diameter. The applied lining performs the following simultaneous functions. Structural shell, incompetent rock, the lining provides confinement and seals groundwater ingress. In weaker ground, the lining acts cooperatively with the rock mass in a composite ring action. Lining thickness is modulated by the extrusion module in response to QLAG-derived ground classification data. Electromagnetic stator surface, the encoded magnetic pole pattern embedded in the lining presents the correct phase-aligned field to the drill train's secondary ring and, upon completion of the bore, to transit vehicle receiver arrays. Dielectric waveguide, the high dielectric constant mineral substrate and controlled void-free cure produce a waveguide quality dielectric layer suitable for integrated communications and sensing signal propagation within the bore wall. Thermal and pressure barrier, the elastomeric matrix provides thermal isolation between the bore environment and the surrounding rock, and withstands the differential pressure of a low-pressure or evacuated transit tube interior. Self-cleaning inner surface, the smooth, chemically inert elastomeric bore surface resists particulate adhesion and is maintained clean by periodic high-velocity air purge cycles requiring no chemical agents or mechanical contact. Integrated wiring conduit, power and data conduits are co-extruded into the lining substrate at defined angular positions, emerging at pre-programmed longitudinal intervals as junction points for switching, sensing, and maintenance access. No post-installation wiring is required. 5.5 high-speed intercontinental transit system. Upon completion of the bore and bore wall lining, the same inverted electromagnetic wave drive stator that propelled the drill train is immediately available as the propulsion infrastructure for the transit system. Transit vehicles are slender, aerodynamically profiled capsules carrying passengers or freight, equipped with a circumferential magnetic receiver array matched to the bore wall stator pole pattern. Operating speeds. Transit vehicle speed is determined by the drive frequency applied to the bore wall stator zones. The bore wall pole pitch for transit operations is 150 mm. Operating speeds at representative drive frequencies are at intercontinental speeds. The bore interior is maintained at low pressure by continuous axial pumping using the wave drive field itself operating on the air column, an application of the Tier 4 cylindrical wave pipe principle from Series 1. This eliminates aerodynamic drag without requiring a hermetically sealed vehicle interface, as the bore wall lining serves as the pressure boundary. Safety, collision management, and redundancy. Because all vehicle propulsion is controlled by the bore wall stator drive electronics, minimum safe following distances are enforced at the infrastructure level. A vehicle cannot physically exceed the speed of the wave zone it occupies. Zone segmentation at 500 meters intervals provides 500 meters guaranteed separation. Emergency deceleration is achieved by phase reversal in the zones ahead of a vehicle, generating regenerative braking force. Head-on collision scenarios are physically precluded in single-bore single-direction configurations. Bidirectional bores use separate parallel tubes standard in this architecture. 5.6 QSGN QLAG navigation integration. The drill train maintains continuous real-time positional lock to the quantum state global network via the Quantum Local Area Grid Interface Pod. The QLAG system, separately patented by Chris D. Seeley, provides absolute three-dimensional position and attitude reference at nanometer resolution without dependence on GPS satellite signals. Surface survey chains, or line-of-sight optical reference, rendering the navigation system immune to depth, rock overburden, electromagnetic shielding, and geographic remoteness. QLAG-derived position data drives the bore path correction algorithm, which commands differential thrust to the port, starboard, top, and bottom quadrants of the wave drive interface ring, steering the drill train on the design alignment with a maintained accuracy of better than 10 mm over any bore length. This enables intercontinental bores to meet at a midpoint junction with sub-meter accuracy from opposing portals, a capability unachievable with any existing navigation technology. Additionally, QLAG ground state sensing ahead of the drill train provides advanced characterization of rock type, joint orientation, groundwater presence, and tectonic stress state at distances of up to 500 meters ahead of the face, enabling proactive adjustment of promethium plasma discharge parameters and lining thickness before the machine encounters changed ground conditions. 5.7 Schumann resonance phase management and seismic attenuation. The bore infrastructure integrates a distributed array of electromagnetic emitters embedded in the bore wall lining at regular longitudinal intervals, capable of generating controlled electromagnetic emissions in the extremely low frequency range of 7.83 to 45 Hz, corresponding to the fundamental and harmonic modes of Earth's Schumann resonance cavity. The Schumann Resonance Phase Management System, operating in conjunction with the QSGN global network, adjusts the amplitude and phase of these emitters to maintain a constructive and stabilizing phase relationship in the Schumann cavity along the bore axis and in the surrounding rock mass. The effect is to reduce the amplitude of seismic standing waves in the local rock mass, providing passive attenuation of earthquake-induced ground motion at the bore and its surface structures along the bore corridor. This does not constitute seismic suppression. Tectonic energy release is not prevented. Rather, the Schumann phase management system influences the propagation and focusing of seismic wave energy in a manner analogous to noise-canceling headphone technology operating at geological scales, reducing peak ground motion amplitude at the bore structure and at coupled surface points. 7. This does not constitute seismic suppression. Tectonic energy release is not prevented. Rather, the Schumann phase management system influences the propagation and focusing of seismic wave energy in a manner analogous to noise-canceling headphone technology operating at geological scales, reducing peak ground motion amplitude at the bore structure and at coupled surface points. 7. Summary of Summary of key innovations. 14. Inverted traveling wave electromagnetic propulsion, in which the bore wall, constructed from processed excavated rock, serves as the external stator and the drill train serves as the magnetic secondary, eliminating hydraulic thrust rams and mechanical coupling to the bore wall. 15. Promethium plasma and maser coupled full-face rock fragmentation, enabling continuous advanced boring in any rock hardness at any depth without mechanical cutter wear or replacement. 16. Onboard debris processing train converting excavated rock to a polymerized, magnetically encoded elastomeric bore wall substrate in a single continuous closed-loop material flow, eliminating spoil removal logistics. 17. Multifunctional bore wall lining simultaneously serving as structural shell, electromagnetic stator, dielectric waveguide, thermal barrier, pressure containment, self-cleaning inner surface, and integrated wiring conduit, all derived from the excavated rock of the bore itself. 18. Use of the same bore wall stator infrastructure, without modification, for both drill train propulsion during construction and high-speed transit vehicle propulsion during operation. 19. Integration of the QSGN/QLAG quantum navigation system for GPS-denied nanometer accuracy boring at any depth and any geographic location, enabling intercontinental bore meet accuracy. 20. Schumann resonance phase balanced electromagnetic emitter arrays embedded in the bore wall lining for passive seismic load attenuation at the bore structure and coupled surface points. 21. Transit system speed governance as a physical property of bore wall stator zone drive frequency, providing infrastructure-level vehicle speed enforcement without onboard speed control systems. 22. Intercontinental high-speed transit at speeds exceeding 5,000 km per hour in a low-pressure bore maintained by the wave drive field acting on the bore air column, without hermetic vehicle sealing. 8. Claims. The inventor claims as the invention the following. 1. A tunnel boring machine comprising a cutting head employing directed plasma discharge and directed microwave energy to fragment rock at the bore face without mechanical cutter contact. A magnetic secondary ring mounted on the machine body and coupled to a traveling electromagnetic wave field generated by coils embedded in the bore wall immediately behind the machine. Said wave field propelling the machine forward without hydraulic thrust rams, and a bore wall lining system that constructs said bore wall from material processed from the fragmented rock of the bore face. 2. The tunnel boring machine of Claim 1, wherein the bore wall lining system comprises an onboard debris processing train including crushing, milling, mineral analysis, polymer blending, magnetic pole pattern encoding, and thermal curing stages, producing a magnetically encoded elastomeric substrate applied in situ to the bore wall. 3. The tunnel boring machine of Claim 2, wherein the magnetically encoded elastomeric substrate simultaneously functions as a structural bore shell, an electromagnetic stator surface for traveling wave propulsion, a dielectric waveguide, a thermal and pressure barrier, and a self-cleaning inner transit tube surface. 4. The tunnel boring machine of Claim 1, wherein the bore wall coil array is energized in phase-sequenced zones by a variable frequency drive system mounted on the machine. Each zone activated as the bore wall lining of that zone achieves structural and magnetic cure, progressively extending the active stator surface forward. 5. The tunnel boring machine of Claim 1, further comprising a navigation system coupled to a quantum state positioning network providing absolute three-dimensional position and attitude reference without GPS, optical or mechanical surface reference, and wherein differential thrust to quadrant sectors of the magnetic secondary ring steers the machine on a design alignment. 6. The tunnel boring machine of Claim 5, wherein the quantum state positioning network provides advanced ground characterization data for rock mass properties, groundwater, and tectonic stress state at distances ahead of the bore face, and wherein boring parameters are adjusted in response to said data before the machine encounters said conditions. 7. The tunnel boring machine of Claim 1, wherein the bore wall lining incorporates a distributed array of extremely low-frequency electromagnetic emitters at longitudinal intervals. Said emitters tuned to Schumann resonance cavity frequencies and phase coordinated with a global quantum network reference to attenuate seismic wave amplitude in the surrounding rock mass. 8. A subsurface transit system comprising a bore extending through the earth lined with a magnetically encoded elastomeric substrate derived from rock material excavated in forming the bore, a plurality of electromagnetic coils embedded in said substrate energized in phase sequence by a variable frequency drive system to generate a traveling magnetic wave field on the bore wall inner surface, and transit vehicles carrying magnetic secondary receiver arrays coupled to said traveling wave field, propelled at speeds determined by the drive frequency without mechanical contact between the vehicle and the bore wall. 9. The subsurface transit system of Claim 8, wherein vehicle speed is governed at the infrastructure level by the drive frequency of the bore wall stator zones, such that no vehicle can exceed the synchronous wave velocity of the zone it occupies. 10. The subsurface transit system of Claim 8, wherein the bore interior is maintained at reduced pressure by the traveling wave field acting on the air column within the bore in the mode of a cylindrical electromagnetic wave pipe, without hermetic sealing of the vehicle exterior. 11. The subsurface transit system of Claim 8, wherein emergency deceleration is effected by phase reversal of the traveling wave field in stator zones ahead of a vehicle, generating regenerative electromagnetic braking force and returning kinetic energy to the drive power network. 12. A method of tunnel construction and transit infrastructure commissioning comprising boring a tunnel using directed plasma discharge and directed microwave energy to fragment rock, processing fragmented rock on board the boring machine to produce a magnetically encoded elastomeric composite. Applying said composite to the bore wall as a combined structural lining and electromagnetic stator surface. And operating transit vehicles within the completed bore using the stator surface to generate a traveling magnetic wave field for contactless electromagnetic propulsion. 13. The method of Claim 12, wherein boring, processing, lining application, and stator energization proceed as a single continuous advancing operation with no discrete construction phases requiring cessation of machine advance. 14. The method of Claim 12, wherein navigation of the boring machine is maintained by continuous coupling to a quantum state global positioning network providing GPS-independent positional reference at nanometer accuracy at any depth and any geographic location. 15. The method of Claim 12, wherein Schumann resonance phase-balanced electromagnetic emissions from emitters embedded in the bore wall lining attenuate seismic loading at the bore structure throughout the operational life of the transit system. 9. Abstract of the disclosure. An autonomous deep-bore electromagnetic tunnel machine and integrated intercontinental high-speed transit system is disclosed. The machine advances through rock using promethium plasma discharge and maser-coupled energy to fragment the bore face without mechanical cutter contact. Fragmented rock is processed on board into a magnetically encoded elastomeric composite and applied in situ as the bore wall lining. This lining simultaneously serves as structural shell, electromagnetic stator, dielectric waveguide, thermal barrier, sealed tube interior, and integrated wiring conduit. The bore wall stator, energized by variable frequency 3-phase drive electronics on the drill train, generates a traveling electromagnetic wave field that propels the drill train forward as the magnetic secondary, an inversion of the cylindrical wave pipe principle described in Sealy UESPP Series 1 upon bore completion. The same bore wall stator infrastructure immediately operates as the propulsion system for transit vehicles at speeds up to and exceeding 5,000 km per hour. Navigation is provided by integration with the QSGN/QLAG quantum positioning network, enabling nanometer accuracy alignment at any depth without GPS or surface reference. Schumann resonance phase management emitters embedded in the bore lining provide passive seismic attenuation. The system constitutes a complete intercontinental transit infrastructure solution in which the construction process itself creates all propulsion, navigation, and operational infrastructure with near-zero subsequent maintenance requirement. 10. Relationship to Series 1 disclosure. This disclosure constitutes Series 2 of a family of related inventions originating with Chris D. Sealy. The relationship between the two series is as follows. 11. Inventor statement and certification. Inventor statement and certification. I, Chris D. Sealy, hereby certify that I am the sole original inventor of the technology described in this disclosure. The inventive concepts described herein originated with me through independent reasoning and creative synthesis as a continuation and extension of the principles established in Series 1. And to the best of my knowledge and belief, the claimed inventions are novel and non-obvious over the prior art known to me. This document is filed as Series 2 of a provisional disclosure family to establish a priority date. It is my intention to pursue formal patent protection for all inventions described herein, in coordination with the Series 1 filing and the separately filed QSGN/QLAG patent family. All rights are reserved. Inventor, Chris D. Sealy.